Let us look at some of the review for the differentiation and integration. Okay, if you notice here, I put the integration as in the bracket antiderivative. Okay, so if you know that if you want to master integration, actually you should master differentiation too, because integration is the form of the reverse of the differentiation. Okay, so over here we're going to look at few of the differentiation and the sum of the integration for your level. Okay, in differentiation, okay, you regardless what level you're going to, the method for the differentiation is only have these four. Okay, the first one is you differentiate directly from the vocabulary table. What is vocabulary table? Actually, it's just like a standard table, which if you differentiate, okay, sine x, you will get this cos x. Okay, so this one I call it as a vocabulary table because this is the thing that is it should be into your uh, mind. Okay, and then later on you will see how then you will have three others. Is what the first one is chain rules, then the second is product, and then the last one is quotient. Okay, this one actually you already learned during your secondary school. Okay, so this is nothing no whether you're going to the degree for taking calculus or advanced calculus. So basically whenever you encounter differentiation, this will be the method you have. Okay, the only thing that is from stages to stages, your vocabulary or the what is the function you can derive is keep on adding to you. Okay, so the method is stick only this four, means is the first one is direct, the second one chain, then product and quotient. Then you keep on adding others, like during your SPM time you learn to differentiate first polynomial. Then during your max 1, you learn how to differentiate sine, trigonometry, exponent, logarithmic. Okay, then in mathematics 3, you're going to learn the inverse trigonometry, hyperbolic function. Actually, these are all the different vocabulary, okay, different types of function that is added into your syllabus. Okay, but contrarily, okay, in integration, okay, integration, we although it is antiderivative, but the thing is, because of the integration, although is revert, but the thing sometimes is quite hardly to identify which method you should use. Okay, some really is by luck. Okay, sometimes it's really by luck. Okay, then definitely by experience. Okay, and don't sometimes you really need to try. Okay, whatever uh, method, okay, or whatever ways you can use to find the integration, because integration, I admit, is a lot harder compared to differentiation. Okay, so in integration are the same. First thing, you can always integrate directly from the vocabulary table, such as just now what I said. When we integrate cos x, we know that actually is sine x plus c, or later on in mathematics 3 you've been exposed, integrate 1 over third 1 minus x squared dx actually is sine inverse x plus c. Okay, this one is the vocabulary. Okay, okay, then after that we going into methods. Okay, when people talking about methods, they always talking about substitution first. Okay, so why over here I put by parts first? Because by parts sometimes sometimes is easier to identify compared to substitution. Okay, but bear in mind that is sometimes in integration you can combine methods into one integration, means that you can do some substitution first, then you change the question or you change the function into another form, then you can integrate by parts or the other way around. Okay, so and by parts you have a very stick, okay, you have a form that you can identify which question you can directly using the by parts. Okay, substitution here, okay, in your syllabus, okay, regardless is like Maths 2 or Maths 3, you only going to use the normal U substitution, okay, and but sometimes if you look, because I know that some of you love to search through the information through internet, and please be aware that is some of the subs, okay, they are under substitution, but in their subs is sometimes they are using trigonometry substitution. Okay, so they are the same way, actually they are same way, but just is they are not commonly replace our substitution u with another algebraic. They are substitute the u with a trigonometry substitution, then you will integrate using the trigonometry vocabulary. Okay, then after that we go, you have one more form is called partial fraction. Okay, partial fraction you already learned during your Maths 1, which partial fraction is very easy to identify, but the thing is sometimes please don't confuse with others form, especially like the trigonometry inverse or the hyperbolic inverse. Okay, and then we have another one is called special type of trigonometry form. Okay, this special type of trigonometry forms are not in your syllabus. Okay, means it's your Asasi syllabus. Okay, but the thing is sometimes I know that is you will see somewhere else. Okay, but the thing is I so that's why I mentioned it over here. Okay, they are during when you're going to degree, maybe you will encounter more other thing, okay, the integration methods or whatever. Okay, because differentiate, that's why I said differentiate is very simple directly, but when you want to revert the thing, then you will be facing problems. Okay, especially some of the question they already go through some simplification, okay, or the simplification or some other substitution, so that's why you will get you hardly can get back your original function, and then definitely you will not forget what is called definite integration. Definite integration and indefinite integration means is one is with a limit, another one is without the limit. Okay, so first let us look at the vocabulary for common derivative. Okay, so the first one actually is the polynomial. So differentiate equals to 1, differentiate x squared equals to 2x, and so on. Okay, then after that we have the standard six of the trigonometry differentiation, which you learn during your Maths 1. Okay, then we learn the differentiate exponent, we differentiate the logarithmic, and then if you really notice here, this one is the vocabulary because this is the standard. Okay, the only thing later on you will see that maybe they combine two trigonometry, or they combine trigonometry with, or with exponent, or they change the x to become x squared, and so on. Okay, and over here we have one thing that is added to you in this slide is differentiate sine inverse. Okay, you no need to panic. Actually, differentiate, this is also just like you just assume it's just like another sine. Okay, the only thing that is differentiate sine inverse, you will get 1 over sec 1 minus x squared. Differentiate cos inverse, you will get this one. Okay, this one you will see in detail in the chapter 4 in Maths 3. Okay, then after that in Maths 3 Chapter 5, you've been exposed to something called hyperbolic function. Okay, in hyperbolic function, okay, hyperbolic function with trigonometry function, the difference is hyperbolic function. We have a h for all the trigonometry, like sine over here have a sine hyperbolic, or you want to pronounce this as sin, sine. Okay, I don't, there is a h at the behind. Okay, so this is the vocabulary, and then definitely we're going to have a hyperbolic inverse, so you will get the another set of the formula. Okay, so now let us look at the first one, what is called differentiation using product rule. Okay, so product rule must be in the form of UV. Means what is this UV? This UV actually is the combination of two different functions. Okay, this must be two different functions, and this is and this function is not a constant. Okay, it's not a constant, so means that when you have y equals to 3x, we never take this as a two different function because 3 is a coefficient, so we can just shift our 3 out, so you can differentiate your x. So for the product rules, always look at whether it is a two different function. Okay, now for some of the polynomial questions, okay, example for y equals to x plus 1, 2x minus 1. Although these are two different functions, you can what you can do is sometimes you can expand it and then you simplify it. So for example, is 2x squared plus 2x minus x minus 1. So you have 2x squared plus x minus 1. So we differentiate from here. So we have a 4x plus 1. That's all. Okay, but the thing is, if you don't want to expand, you want to treat this question as an UV, there is nothing wrong. Okay, you can use the UV as a product rule, also doesn't matter. The only thing that is maybe your working is a little bit longer compared to your friend. That's all. Or most probably you'll be ended like 3 rows. Okay, so it depends on how you do your UV. Okay, so now I think you already memorized last time when we have a UV, so it's UV prime plus VU prime. Okay, they are the same. So now let us look at one of the examples, x and sine x. Okay, so x is one function, sine x is another one function. So regardless you have some other thing, it's just like sine inverse x also, your method to do it are the same. They are still two different functions. The only thing that is when you want to differentiate sine inverse, you look at the table. When you differentiate sine inverse x, what do you get? Okay, so like you differentiate sine x, you look at the table, you will get cos x. So when we differentiate sine inverse, you will get 1 over square root 1 minus x squared. So there is nothing special over here. The only thing that, because if you move on into Maths 3, your vocabulary has been added. Okay, so now, so doesn't matter which one you want to choose as an u. Okay, you can choose your u as an x, or you can choose your u as a sine x, doesn't matter. Okay, then first thing, after you choose your u, then you find the u dx, or you can use u prime. Then we have v prime equals to cos x. Then we just substitute everything what we found just now into the formula. So we have a x cos x plus sine x. Okay, if some of it maybe can be simplified, but this one, since nothing can be simplified, just leave it as it is. Okay, then the second one is quotient rule. Okay, so the difference between quotient rule and the product rule is quotient is one u over v. Okay, maybe some of you that learn that maybe you don't like quotient. Okay, maybe some of you will use u y equals to uv negative 1. Can, no problem, but with one condition, that is, don't confuse this negative 1 letter. Okay, okay, especially when you go to the trigonometry inverse, okay? Because for example, when you have y equals to x over sine inverse x, okay? So this one actually is x sine inverse x minus 1, okay? So this one, this minus 1 is not meaning inverse, okay? The sign negative 1 here is meaning is inverse. This one is the power negative 1, okay? So don't mix up this notation, okay? Okay, so now if you want to use quotient, so definitely it's like you need to identify who is u, who is v, then follow this formula, v square v u prime. Okay, maybe what we learned last time, v square v u prime minus uv prime. Okay, they are the same. Okay, so when we have the question x over sine x, so you identify the one the top, okay, nominator will be your u and denominator will become your v, okay? So you differentiate normally, then you substitute inside. Okay, if you see whether you can simplify or not, if not, then you just leave it as it is, okay? Then after that, now we go to the chain rule. Okay, chain rule means that is, you know, the chain is like you have they are linking together, okay? So you do one by one, okay? So chain rules, they are the most simplest one is just like this one, okay? So you want to differentiate y, okay, but in your vocabulary you only have differentiate y equals to sine x, okay? But the thing is how you, but the question now here is 2x. So what you can do is, okay, you just substitute, okay, you just substitute your 2x to become u. So you're going to have y equals to sine u now, okay? So when you have a sine u, so it means that when you differentiate, you will get dy towards du. So you will have a cos u. But the problem is the question asking you to find dy dx. So you learn during the chain rule is dy dx actually is dy du, then du dx, okay? So this is the chain rule. So means that you first thing you differentiate towards sine, and then you differentiate towards what is inside the function of the sine is 2x. So maybe for example, maybe you can have some more tedious one. You have a exponent sine square root of x, okay? So this is another way, another form of you can solve it by using chain rule, which you need to tackle who is the bigger picture, okay? So we will have, when we read, we will say this is exponent, the function of exponent towards sine, and your sine with the square root of x, okay? So when you want to do the chain rule differentiation, you need to identify who is the bigger picture here, okay? Or some last time I used to tell my told my student is who is the anak, okay? Who is the one the most, okay? So over here, square root of x belongs to sine, sine belongs to exponents. So actually the cucu here actually is square root of x, then sine is the anak, and then e is the father. Okay, so when you do the differentiation, you chain rule, by using chain rule, you need to do it one by one. Okay, okay, now after that we go to implicit differentiation. Okay, implicit differentiation is a bit different compared to the previous method. Actually, why is come with an implicit differentiation? Because the equation itself is not linear, okay? Because you have the combination of y and xy and so on. So what you need to do is just you need to identify what is the title, okay? So when the equation is written as y5 minus y power 5 minus y equals to 5x, okay, you need to look at the question what they are seeking. When they are seeking dy dx, so you need to know who is your y, who is your x. Okay, so when we then after you identify, then you can do the differentiation implicitly. Whenever you see y, okay, whenever you see y, you eat one of part of it, it will become dy dx. So when you look at the x, so because when we differentiate x towards x dx, it will become 1. So that's why you never see dx over there. Okay, so then you y power of 5, then you just differentiate as a normal chain rule. Okay, so push the 5 to in front. 5 minus 1 is 4, and then this is an y, so you differentiate y towards x, so you have a dy dx because you cannot cancel of it. Okay, so that's why I said when we differentiate 5x towards x, okay, so because of then the 5 we can put in front. When we put the 5 in front, dx over dx actually is 1, so that's why you have a 5. Okay, so because the question asking for dy dx, so you need to shift your friend going down here, so 5 over 5y y power 4 minus 1. Okay, so this one is implicit. Now let us move on into our integration. Okay, in integration also, okay, because as we know just now, integration is the revert of our differentiation. So the set of our vocabulary are similar to the one in differentiation. The only thing that now is the revert part. Okay, so the most common one is when we integrate the constant, it will become kx plus c. Why? Because when we differentiate, 3x is equals to 3. So when we integrate 3, okay, means that we revert back here, so you will get 3x. Okay, but why you have a plus c here? Because we need to do this, all the assumption that is, we never know that is when we have we differentiate 3x minus plus 5 and we differentiate 3x minus 1000, both will give you 3. Okay, so, or even we only differentiate 3x, we also getting 3. So we can't identify whether the constant value is there or not unless people give you others information. Okay, if not, then we have to just by default we have to plus c back into it. Okay, okay, now I think you still remember. Okay, so whenever we want to do differentiation for the power of n, so we push our n towards in front. Okay, then n minus 1. Now this one is become revert. Okay, so differentiate x power of n. So we push our, first we push our n in front, then our x minus 1, this one is number 2. But when we do revert, this one will become first, so your x will be plus 1 first. Okay, and then this is multiplication and it become divide. And divide of what? Just now you plus 1, so divide n plus 1. Okay, totally, as you can see, that is integration is always totally revert of your differentiation step by step. Okay, and then one thing that is this is the question, most of not integrate x minus 1 or integrate 1 over x. Okay, this is the questions always the student will get wrong. The reason is lack of your understanding of the vocabulary, because you already by default you saw 1 over x, your brain only pop up one thing. Okay, so x, I go in front, I bring it up -1, so I plus 1. Okay, although this one is 0, and then you still will be just taking like x0. Okay, or you just say this is 1. Actually, don't forget, when you have divided by 0, this one is undefined. Okay, so from there you already can know that this is not a power. You cannot integrate 1 over 1 over x using the power rule. Okay, so means that look at the vocabulary you have. Actually, if you become ln absolute x, why there is an absolute over here? Because logarithmic must be the value of the logarithmic must when the logarithmic only can take positive value. Okay, so happen to the one in the form of ax plus b also is logarithmic. Okay, then one thing that is very special about logarithmic is you can only differentiate logarithmic, you can't integrate logarithmic. Means it is the vocabulary. If you look at the vocabulary, it doesn't exist integrate ln u, ln x. It will be existing is only integrate 1 over x dx equals to ln x plus c, or you differentiate ln x is equals to 1 over x. Okay, don't mix up both of this formula. Whenever you saw you need to integrate ln u, okay, you need to integrate anything is not inside the vocabulary, means that you need to use some method. Okay, so definitely you already know that is you already learned in your max 2. Whenever you see integrate ln u, so you need to use one of the method is called integration by part. Okay, then we have the vocabulary integrate exponent u is to get back exponent u as usual. And this one 1 2 3 4 5 6, this one is the vocabulary for the trigonometry. Okay, so have excuse me, I think it's until here. Okay, this is 2 4 6. Okay, this is the vocabulary of trigo, and this 2 is not in your vocabulary table, because you only have differentiate tangent is secant square. That means you integrate secant square, it will become tangent u. So but now when the question asks you to find integrate tangent u, means that when you check it's not in your vocabulary, means you need to use others method. Okay, so if you look at here, why they have this one? Because some of the subject, okay, from others university or whatever, they will ask their student to memorize this. But for us is especially for me, I not encourage you to memorize. So actually you can integrate tangent u, and then you will get ln secant u by using integration by part. Okay, and over here we have the orange color one. This one also is the one in your chapter 4, is the integration of inverse trigonometry. And then this one is the integration of the hyperbolic function and integral involving inverse hyperbolic function. These are all are the vocabulary, because whenever you look at this question, integrate cos x dx, you automatically you give me the answer is sine hyperbolic x. If you look at the question, integrate 1 over a square minus u square, then vocabulary tell you is 1 over a tangent inverse u over a. Okay, this one you need to be a little bit be careful. Okay, for the student who take max 2 and max 3, the main reason is because this question will give you two different answer. Okay, by using two different methods. The first method is you using directly using the vocabulary is inverse trigonometry function. Then the second one actually is a partial fraction. Okay, so it means that this question itself you can use. The first one is this answer. This is the first method. The second method is integrate 1 over 1 minus x, sorry, a minus x, a plus x, okay, dx. And this one you can use a partial fraction, change it to become a minus x plus b, b plus x. Okay, then you can solve using this one. Okay, so this is the interesting part of integration, which sometimes one questions, okay, and if you look at it, when people think differently, you will get different answer. But the thing is, none of it is wrong, as long as you are following the correct method or the correct vocabulary. Okay, and please don't simply change the thing. Okay, when you use whatever things information from the vocabulary, it must be look exactly the same. Okay, so for example, if this one is a square minus u square, okay, but your question, let's say your question is 1 over a square plus u square, and please don't think that you can bring this minus going in. Okay, this is a square, so that's why whenever you want to use the vocabulary, please look at the formula clearly. Okay, especially you need to compare terms by terms. Is it they are bring the same meanings or not? Okay, now this is integration by part. Okay, so this is the general integration by part. Okay, and this one is a little bit there over here have a little bit difference compared to your max 2, because your max 2 telling you is LOPET is LOPET. Okay, but over here we have, because in max 3 we have something called inverse trigonometry. Okay, then we have an inverse hyperbolic function, so that's why over here have an extra I in front. Okay, and the O actually is nothing. Then in max 2 we use the term polynomial. Over here they use as algebraic. And now this one in max 2, the term is ET, exponential trigonometry. Over here they put as a trigonometry exponential. Actually, because of exponential and trigonometry, both of them are very stubborn. Okay, why is I say they are very stubborn, especially like exponential? Regardless you differentiate or integrate, it will never change. And then our beloved trigonometry also quite stubborn also. They will just change in form. From sine, they change it to cos, cos change it to become sine, or tangent change it to become secant, and so on. Okay, and not like our x polynomial, it will get disappeared. Okay, why? Over here inverse is at the top here. Okay, the main reason is we only actually I think should be sine, and this one they should be stand together. Reason is sine inverse also. Okay, we can only differentiate, we cannot integrate. Okay, the main idea of integration by part actually is you need to choose the suitable candidate for U and the candidate for DV. Okay, so who are the candidate can be U, who can become the candidate of the DV? You need to make sure one thing only. Okay, we want a candidate, okay, U, okay. If possible, we want our U go disappear, okay. So then the one of the function will go disappear. That is the first thing. We want our U disappear. And then the second thing is, when you want to choose the candidate DV, you need to make sure it can be integrated. Most of the function can be differentiated, but not all the function can be integrated directly. So that's why when you look at the question, you need to identify who can, okay, if both can differentiate, both can integrate, fine. Then you need to choose who can be easier to go disappear, so that person will become the U. Okay, so this is the main reason why the logarithmic you will be the first candidate to choose as and your U or the sine inverse, because they cannot be integrated. Okay, they cannot integrate directly, but they can be differentiated. But our x compared our polynomial x cubed, to compare with our trigonometry, okay, both of them can be differentiate, both of them can be integrate. So when these two combination, why we choose u as our polynomial? The main reason is when we have an x cubed, differentiate one time is 3x squared, differentiate another time will become 6x, then you differentiate again, you will get 6. So the x is go disappeared, but not going to happen to your sine or exponent. They will be very stubborn, will be stick there forever. So that is the main reason how why they arrange this the choice of u and dv in the form of Lopet, or this is I E Lotte, okay, whatever, okay. So that is the reason. Okay, then now this is the trigonometry, okay, trigonometry integral, okay. So this one actually, okay, this one is only additional information, okay. This one is additional information, okay. This one you are, okay, the student who are going to degree, okay, there is a chances you will see this excuse me, this topic in the calculus during your year 1. If not, okay, if not, you are not going to see it again, okay. The over here, if you see, that is first thing, this one is involving sine and cos, okay, and if the power of the sine is odd and positive, so this one is the combination, the combination of the sine and cos, okay. If the sine is odd and positive, you choose your u as a cos x, okay. So one of the examples, just like integrate sine 3x with a cos x, okay. So then this is the meaning of this one, okay. And then if revert, if your cosine is odd and is positive, and then you choose u as a sine, and if both of them are sine and cos are positive, so you use the half angle identity, okay. Okay, so this is the extra information, okay. And then if really happen, if the combination of the secant and tangent, okay, so they are following the same trend as the sine. If the secant is even, you choose tangent. If the tangent is odd, you choose secant. And there is if there's no secant, excuse me, then you use the trigo identity, okay. So then that's all, okay. And over here you see there is a remark. If nothing else works, convert everything to sine and cosine. Okay, so that's why integration, why most of the students don't like, okay, because it is not a standard form, because you have, especially when you involving trigonometry, when you go into degree, they are 1000 of one combination. Then you really have to try your luck, or you look at dig into your experience, okay, which one is work, okay. I have to admit also, sometimes I myself also need to try, because especially the question is not by me, then I also need to try, then I need to see which combination is better, okay. Okay, then we have one more, the one is the one you learn, u substitution is the normal substitution. But if you look at this trigo substitution, is whenever you saw, okay, whenever you see the question is in the form of integrate sert 3 square minus x square dx, okay, this one is not in your vocabulary, okay. This is also not, okay, sometimes please don't confuse 1 over sert 3 square minus 2x square dx. This one is in your vocabulary, but this one is not, okay. So when this type of question coming out, then the substitution you can use is you substitute the x with a sine x, then you change the question. Okay, what it means by you can change the question. So now, set. Okay, 3 square you will never change. X, I will change it to become A sine. Okay, since this is a is 3, okay, the A is 3 because it's follow this one, so it's 3 sine square theta. Okay, then I factor out. Okay, then dx is I need to okay, so my x equals to A sine theta, so dx dA sorry, dx d theta is A cos theta, or my dx actually A cos theta d theta. Okay, so the dx will change to 3 cos theta d theta. Okay, now what happened to this square root? So I took out the 3. Okay, I took out the 3, so I'm going to have my 3. Then inside will become square root of 1 minus sine squared theta, then 3 cos theta d theta. And if you can remember, 1 minus sine squared theta actually is cos theta. So now the thing will be cos squared theta, so this one will become integration of 3 cos theta d theta. Okay, so you already changed your question to become integration of 9 cos squared theta d theta, and this one you learn in your Max 2. You cannot integrate cos squared, you only can differentiate cos squared. So change the cos squared to become 1. Okay, we have 1 cos 2 theta equals to 2 cos squared theta minus 1. So our cos squared theta actually is cos 2 theta plus 1 divided by 2. So this one will become integration of 9 cos 2 theta plus 1 over 2 d theta. Then you already integrate using your vocabulary combined with the chain rule. Okay, the substitution. Okay, so this one also not in your Max 2 thing, but the thing is I just one shot telling you what is the common substitution you can see. Okay, so now first thing, now this is the way you will learn, okay, during your Max 2. The first one is a substitution of u. Okay, so when we want to look at the substitution of u, okay, whenever you look at any form of substitution, okay, it must be consist of two different function, okay, like your product rule, okay. But here you need to be careful one thing. For the substitution, whenever we have an fx and gx, okay, either of it is the differentiate of the other one, okay. So means that when you have an fx, then you look at your gx. Is it this gx is the integration of your fx, or if this is the differentiation of your fx? Okay, so if they are in this kind of a combination, then it's a substitution. Okay, so for example, is the one very simple we can look at is, let's say when we have an x cubed here, the inside is x power of 4 plus 1 power of 10 dx. Okay, so then this is two different function, okay, and then although this is a power of 10 whatever, maybe you have others way to identify. So but these two function, if you look at this is x power of 3, this is x power of 4. We know that is x power of 3 is the differentiation of x power of 4. Okay, this one is plus 1. If this is plus x is not working, then is x power of 4 plus 1 differentiate will get x power of 3. So we know that is x3 is differentiation of our x4. So this will be our candidate of our u. Okay, because later on, after you use the substitution of u, what is going to happen? The first thing is we choose our u. Later on, we are going to differentiate our u. When after the differentiation, okay, when you substitute the dx over here with a du, then definitely your x cubed will disappear. Okay, so then you will left out with the term with u. Your x should be everything disappear, and then after that you integrate it, then replace all the u with your x. Okay, so for example, one of it is sine 2x or cos 2x. Okay, this question is not that it doesn't mean that you must use substitution. Okay, it's not a good example, especially this also. Over here they use the u as a sine 2x. Definitely you can use your u as a cos 2x, because sine differentiate is you getting cos, cos differentiate you are getting sine. Okay, so both of them are the differentiation or the integration of each party. You can choose either of it. Okay, so you differentiate, you will get 2 cos x. Okay, definitely you need to get the dx, so you substitute into your dx, so you will get this one. Okay, so then integrate u squared this one. Okay, now for this question, okay, whoever is alert with the trigonometry function, actually you know that is you no need to use the substitution. Actually, you can use the trigonometric identity, change this question into another form. Okay, because why? We know you learn that 2 sine A cos A actually is cos 2A. Now you only have a sine 2x, cos 2x actually is going to become, this one is sine. So you know that the 2 bring here, you become 1 over 2 sine 4x. So this question you can easily solve it by integrate half sine 4x dx. So you will get half negative cos 4x plus c. Okay, that's all. Okay, then maybe some of you will argue these answers are not as this answer. Okay, now you need to remember, okay, sine squared 2x, anytime you can change to cos 4x easily, because remember just now we already used 1. Cos 2x actually is 1 minus 2 sine squared x. So this one can change to cos 2x. So this one can change, sine squared 2x can change to cos 4x. Okay, then the second one is this one is the normal substitution. Okay, if you want to use the substitution way also can. If not, you can integrate normally. Just integrate sine, you will get cos. Okay, then because of inside there is a 3x plus 5, so you are going to divide it by 3. Okay, remember one thing, that is when you use this sort of thing, the vocabulary is a linear. Okay, it is never quadratic or cubic and so on. If you involving quadratic, cubic, then you need to find others way to do it. Normally you will start with a substitution. Okay, now then we look at the integration by part. Just now we already saying that is okay. They are in the max 2 we follow LOPET, logarithmic, polynomial, exponent, and trigonometry. Why I highlight the ET? Because you can have an LOPTE, because that ET are interchangeable. Okay, so when are you going to use LOPET? Okay, first thing, if you see, you have two different functions, 2x and sine x. Okay, they are not related to each other. Okay, they are the combination between polynomial and sine, which you integrate or you differentiate, x cannot be getting sine. Okay, so when this happens, then you look at it is follow the integration by part. Who to choose? Okay, since you already provided by the formula LOPET, so polynomial come first, trigonometry come last, so directly you just choose the u as 2x. Okay, if you don't want to use the u equals to 2x, you can always keep your 2 outside, also doesn't matter, but don't forget to take it back later. So your u equals to 2x, dv equals to sine x. So you need to differentiate the u, because okay, the formula is this one. okay, integrate u dv, actually integrate u dv, u is equals to uv minus v du. Who is the u? Is the one the u you have. So then dv is the choice you have. So that's why you need to follow, substitute back exactly following uv minus v integrate v du. So then you substitute, you differentiate, getting du, and then you integrate, you getting the v. So you substitute inside, and for the integration by part, please always be careful with the minus, because it's minus v du, and especially for your v or du consists of negative, please be careful, okay, because this one and this multiply is a plus, okay, so just beware. Okay, then after that, then don't forget to integrate, okay. And then now, because in the Max 3, we're going to use tabular method. Okay, so tabular method is solving, okay, over here, tabular method, solving integration using integration by part, okay. So this one, tabular method, is you put your integration by part into integration by part into a table, okay. So one side is, okay, if you see that is, okay, the case 1 over here, one function either y1 or y2 can become 0 after differentiating a few times. Okay, so this one is basically when it's involving like polynomial. Okay, like our x power of 3 or 2x plus 1, okay, and so on. As normally the one can go become 0, normally is polynomial only. Okay, polynomial with the positive power. Okay, so how you build the table? The sign over here is alternating, positive, negative, and so on. And the first column is you choose who is the one can be differentiating, okay, and if you can, after a few times you differentiate, it goes 0. And then the second column will be the one you need to integrate it for many times. Okay, so now let us look at one of the example. So integrating 2x sine x, that is the question before. Okay, so we know that 2x is the one can become 0 after differentiating, and the sine, you cannot go 0, so it will become integrate. So what you need to do, build the table. Sine is positive, negative, positive. Okay, then we put the one can be differentiating as 2x. So differentiate 2x is 2. Differentiate the 2 is become 0. Over here is writing as differentiating for twice, so it's 0. And when we integrate sine is negative cos. When we integrate cos is negative sine. Okay, and this one is a bit magic. Okay, so how you want to read this table? Start from the sine. Positive multiple 2x is 2x. 2x multiplied with the negative cos x. So then you have a negative 2x cos x. Then the second arrow, you're going to have a negative multiplied by 2, then multiplied by the negative sign, so you have a 2 sine x. Okay, because this one is already 0, so definitely you no need to go for the fourth row. So then your final answer, just combine these two, and then you put a plus c at the behind. Okay, then the case 2, okay, if the case 2 here, both y1 and y2 can be 0 after differentiating a few times, okay? So means over here, so you differentiate, the table are the same, the table are the same. So it doesn't matter who can be in the differentiate, integrate. What you need to do, there is an extra alert actually is over here, okay? Okay. You look at the both case which cannot be differentiate, that will not leads to 0 when differentiate. So we just simply choose the ex as our differentiate. So you differentiate how many times also ex, and then you integrate how many sine will become negative cos will become negative sine, and so on. Okay, now The problem is when to stop. Okay, when to stop is very simple. If you look at it, okay, this is EX, this is EX, this is sine X, this is sine X. So means that they already repeated the same pattern, so you stop. Okay, if they are not in the same pattern, you cannot stop. Okay, so how to do it? How to do getting the answer? Same as the previous one. 1 multiplied EX multiplied this one, but when this one is the same one, you go straight diagonal, horizontally going this way. So that's why you have this one. Okay, now because you going this way is going the one straight here, please put integrate over here. Okay, and this normally is your question, so you need to shift it to the other side. So you become 2, and then you divide it by 2, and then put a plus C. Okay, so this one, maybe some of you, I think most of you later, you're just saying that tabular method is a lot easier compared to the integration by part, because you no need to integrate one by one. You no need to choose your UV many times. Actually, this one is almost like you already choosing the UV differentiating many times, just you didn't write it properly only. Okay, so now the method we already finished. Okay, so already finished. So that is basically you will see in your Max 2 and Max 3. Okay, so but because there is an extra, some of it is a bit weird. Okay, so like the one I said, trigo substitution. Okay, you use the substitution, but it's a trigo substitution, or the sine is power of 2 and so on. It's not in your syllabus. I have to remind you again, that is not in your Max 2 syllabus, nor not in your Max 3 syllabus. But just because of they always come in a package. Whenever you Google it, they always come in a package. Okay, okay, so now let us look at first question. Okay, so this one, if you can see, that is this is then definite, because over here you have a limit. Okay, so if you want to solve this question, if you don't want to keep on putting the limit, so you first thing, you can always change your question into the indefinite question first. Okay, then after that, whatever you want to do is easy. Okay, if not, if you have the question of substitution, okay, actually this is a question, okay, if not, then you have to change the thing is copied or whatever many times. Okay, now if you look at this question is two part. Okay, if when this is have a nominator and denominator. Okay, so okay, what is the things you need to do first when integration? First thing, you look at the question. Okay, then when you found out it is not in your vocabulary, okay, then you only take out, you know that you only have how many methods? Use substitution, integration by part, and then partial. Okay, when partial, okay, when we see, okay, then my skill is always try to kill off others method which is not fit in. Okay, first I look at the question. This one cannot be a partial fraction because there is a square root at the denominator. So that means partial cannot. And then is it integration by part? Okay, you learn that your integration by part is then in the log-pad form. So this one for temporary is not a integration by part. Okay, so then you left out is substitution. Okay, so then when we have a substitution, then now you are looking at your function. Okay, either you want to have the nominator is x squared, denominator is combined with a square root. Okay, then x cubed plus 1. Okay, then you need to think critically is either you want to bring your square root together with you or not. If the one, then you have only have x cubed plus 1, or you can choose x cubed. Okay, it's up to you, doesn't matter. Okay, so because substitution are too linear, that you can have many ways to substitute. Okay, but the thing is, for this question is not suitable to bring the square root together. The reason is we don't want it to be troublesome. Okay, why? Because when you choose, if you choose u equals to x cubed plus 1, 1 over 2. Then when you do differentiation, okay, actually it's nothing wrong. Actually, it still can happen. Okay, negative 1 over 2, then differentiate 3x squared. So you're going to have 1 over 2. Okay, sorry. You're going to have 3 over 2 x squared over square root x cubed plus 1. Okay, and then this one is du dx. If you bring the dx up here, okay, so this one is dx. And if you look at here, this one, okay, it's totally exactly the same. So you just send this one up here. So you have 2 over 3 du actually is equals to x squared over square root x cubed plus 1 dx. Okay, so this is this part. So what you need to do, you just put back integration. This is integration. So you just integrate 2 over 3 u plus c. Okay, now, but since this question is okay, then change back the x to x. Your u is x cubed plus 1 over 2 plus c. But our question is with limit. So what you need to do is just change back, integrate 0 to 2. Okay, your question is equals to integrate 2 over 3. Is 2 over 3 x cubed plus 1 over 2, and you put your limit to 0. Okay, this is one way. If not, okay, if you want to carry your integration limit together with u, at this moment you need to change. Okay, how to change? When x equals to 0, your u equals to 1. When x equals to 2, your u, okay, 2 is 8, this is 9, is 3. So you're going to integrate 1 to 3. Okay, so you're going to change to 1 to 3. Okay, so then this is how you do the substitution, definite substitution, u substitution. Okay, this is only one of the example of one of the choice of your u. You can choose your u as x cubed plus 1. Okay, so du dx, okay, du is equals to 3x squared dx. Okay, this one actually is your this part. Okay, so now your question will become 1 over 3 du over third u. Okay, this is also another choice, which this one actually is u negative half. Okay, or if you don't want, you can choose your u as x cubed. Okay, so that's why in integration you have many ways to do the substitution, especially this type of a basic question. Okay, okay, and no one can say who is better. Okay, as long as you can finally settle the whole thing. Okay, now we look at our second question. Okay, the second question is not two part. It's not means it's not the numerator and denominator. Definitely our partial gone. Okay, and then after that you look at it, it consists of two different functions. When this is two different functions, the first one is a polynomial. Okay, since third t we don't like, you can change to t half, and then it's combined with ln t. Okay, then you in your mind you know that differentiate t or differentiate ln t. Okay, especially differentiate all this one you cannot get. And then especially you see that ln t and the combination of t, actually this one is the cannot be integrate, it cannot be substitution, okay, because if it can be substitution, not suitable. Okay, and then but the thing is this one actually is integration by but because it's the combination of a polynomial and logarithmic. Okay, and then now the next question is 3x cos x squared. Okay, although are 2, and although this one is the polynomial, and then this is a trigonometry, and also in our LOPET, we have an LOPET, so it's a polynomial and trigonometry. Okay, but before we want to go to the LOPET, look at it first. Okay, look at the function. This is x squared. This is x. Okay, when this is x squared, this is x, then your mind should become up one ding ding. It means that there is a chances they are substitution. Okay, so what you want to substitute with? I not because there's no cos here. The relationship is x squared and x. So my substitution actually is x squared. So du equals to 2x dx. So I bring the 2 here, out down here. So this one disappears. So I'm going to have integrate 3 over 2. Okay, x dx is this one. And then I'm going to have my cos u du. Okay, so integrate cos is equals to negative 3 over 2 sine u plus c, then change back your u become x squared. Okay, then now you look at the question 4. Okay, whenever you have a two part, okay, denominator and numerator, don't straight away jump to like partial fraction or whatever. First thing you see, can it be simplified or not? Yes, it can be. So it will be turned 1 over square, okay, over theta 2. So you integrate this one. And then this one actually is a theta negative 2. This one actually is theta 2 d theta. So you integrate normally. And this one is x. And this is also x. So this is actually is integration by part, LOPET. And then this one. Okay. This one, okay, for your information, okay, when you have a partial fraction, okay, so this one can always be right in a you learn during your max 1. When partial fraction means that the denominator is the either is the linear, okay, linear factor, or is a quadratic, okay, unreducible quadratic. Okay, so when it is an unreducible quadratic, you always, okay, still remember that time when you have a combination of this one. So what you do is you change to a over x plus bx plus c over x squared plus 1. Okay, unreducible quadratic, your top you always put is bx plus c. Okay, but seeing here there is no bx plus c, so you cannot use substitution. Okay, so that's why last time when you learn in your max 1, that is the purpose of your partial fraction. When you have an unreducible factor, why you need to put bx plus c at top, because later on you're going to integrate by using substitution. Okay, so since this question is not in the form of a bx plus c at the top, you cannot substitute. But this one, and then you cannot use the, it is an irreducible factor. So means that this is not a partial fraction. This is not a substitution. Actually, if later on you look in max 3, actually this one is a tangent inverse. Okay, so actually this one is, look at the vocabulary, actually is a tangent inverse. Okay, and then now we look at our question 7. Okay, when we look at our question 7, x5 as at top, okay, x3 at the bottom. Okay, in our mindset is, or we already learned, okay, always the 5, okay, the higher power is going to become the u, and then the lower power is going to become the it normally can be cancelled off and so on. Okay, but don't forget you have a square root. Okay, whenever who have the square root, they're always the weird one. So we need to tackle the square root. Okay, so now when you will, because this is not definitely not partial fraction, this is not integration by part, must be a partial fraction, it must be a substitution. Okay, so when you want to do substitution, we always look at, okay, if fx and gx, we see who has a higher power and so on. But one thing need to bear in mind always is, whenever you have a square root, there always is the king. Okay, so now what we want to tackle actually is the one substitute inside here. So x cubed, okay, our u actually is x cubed plus 1. So du is equals to 3x squared plus, actually our du is equals to 3x squared dx, okay? But now you can tell me, it is x power 5, but here is x power 2, okay? Recall, x power 5 actually is x power of 2 multiplied x power of 3. So now this one will become, okay, we just ignore the limit first. So integrate x3 x2 divided by square root x cubed plus 1 dx. Okay, so because of this substitution, okay, this x2 dx, okay, then this one bring here 1 over 3 x2 dx actually is your du, x cubed, okay, what is, okay, then over square root u. Then you asking, so how about x3? So you look at your u is x cubed plus 1, so shifted your plus 1 to the other side, so you're going to have a u minus 1. So then now simplify 1 over 3 sub u minus 1 over sub u du, or actually this one is u half minus u minus half du equals to 1 over 3. Then you after okay, let's say this is 1 3 over 2, then please make sure, okay, 2 over 3, change back your u into the x cubed plus 1. Okay, so that's why not necessarily must be the higher power will become your u. Okay, and then look at this one is stand alone. Okay, then it's a third. So how to do? Okay, please don't make funny integration. Okay, so use what the knowledge you learned during the max 1. Okay, how to change the power of third into the exponent. Actually, this one actually is integrate t over 2 dt. Okay, this one, okay, because sometimes you already learn so many advanced things, when suddenly you've been introduced a very simple question, you tend to get confused. Actually, this one nothing trick. There's no trick. This is x half plus 2x plus 1 half integrate. The only thing that is, remember this one, okay, there is a 2x plus 1. If you want, you can use substitution. If not, then you directly per 2. Okay, then we have this one. Okay, if you look at this one, definitely you will know that it is not in your max 2, it's in your max 3. It's going to be in your chapter 4. Okay, so normally we're going to chapter 4 later. Okay, then you look at this one. Okay, et1 plus 1 plus 2 et, okay, and nothing else. So what? Okay, definitely it's not partial fraction, it's not the integration by part, so it's substitution. Okay, so, and then one more trick is, one is either we see our friend square root, and the second one who is at the denominator. So let our friend at the denominator take everything, u equals to 1 plus 2 et, so du equals to 2 et dt. Okay, so this is et dt, so these two bring down here, so you're going to have integrate 1 over 2. Okay, et dt actually is your du over u. Okay, then you just integrate as usual. Okay, then now, okay, now the question 12 is the one I say is not in your max 2 or max 3 syllabus, okay, which they have a very special combination where your sign is even, okay, the power of your sign is even, and the power of your cos is odd. Okay, so it already said, so whenever you see the cos is odd, okay, sorry, I think I need to check back. Okay, I need to check back. So whenever you see the, okay, so whenever you see who is the one is odd, you will choose the other one as u. Okay, so this question is you are going to choose, okay, this one is an odd. Okay, so since the sum is an odd, okay, so since the cos is an odd, so what you need to choose, your u is the sine x. Okay, so du equals to cos x dx. Okay, now what happened is, okay, here, ignore the limit. Sine is u squared, then cos 3 is cos 2x cos x dx, because I only need cos x dx. Okay, so now cos x dx is du. What happened to my cos squared x? Cos x, remember, cos squared plus sine squared equals to 1. So cos squared actually is 1 minus sine squared. And what is sine? Sine is u squared. Okay, so this question we change it to become 1 minus u squared du. Okay, so you are going to integrate u2 minus u4 du. Okay, so then this is u3 over 3 minus u4 over 4 plus c. Okay, then u actually change back to become sine, so you're going to have a sine cube x over 3 minus sine power of 4x power of 4 plus c, and then this is your answer. Okay, so that's why this have a special pattern for you to change. Okay, then for this question, very easy. Whenever you see arctan is your in your Max 3 chapter 4. Okay, then this one, as I said just now, when have a square root below, you cannot have a partial fraction. So that means it is not an integration by part, must be a substitute. Who can be substitute? Always is, normally is the one in the square root. Okay, so this is your candidate. Okay, then now, this one is not a partial fraction. Okay, then either it can be substitution or it's an integration by part. But this question is the combination of a polynomial and a exponential. So this one is the log pad. Okay, then we look at this one. Okay, this one even very simple. Okay, you see these two are the same. Okay, but the thing is maybe sometimes we lack of the experience of example. Okay, remember when square root and ln, okay, ln x and square root, when we differentiate, okay, it tends to go underground. Differentiate ln x is 1 over x. Differentiate square root is going to become 1 over square root. So, excuse me. So, this question, we didn't use this as a below substitution. Actually, we try to substitute is in the inside. That is one keyword. Then the second keyword is, normally we will substitute something for like cos, exponent, and so on. Okay, we will when a combination with a cos and a polynomial, seldom we want to substitute the one denominator without the cos and so on. Okay, so actually this one is a substitution u of a square root 1 minus x. So you will get, you make the one below disappear. Okay, what it means by go disappear? Okay, so du equals to 1 over square root 1 minus x. Okay, there is a minus here because this is a minus, and then the dx. Okay, then you have a 1 over 2. Okay, so or I write it here, 1 minus x power of half push in front, then half minus 1 is negative half, so going underneath, and then there is a minus here, so the minus is in front. Okay, then you can see dx 1 minus x is this thing. Okay, so means that the rest sent over here. So this question will become integration of negative 2 cos u du. Okay, so then you can proceed. Okay, so same thing happened to this one, also same. Okay, so now one thing that is this question, okay, this is not a substitution. Okay, maybe this is also a substitution, but this is not a substitution or the normal substitution in your Max 2, but this is in Max 3. The reason is this one is ex, this is e2x. Please remember, okay, not necessary that is you see ex, you see e2x, we thought that they are same. Okay, so they are not the same. Okay, this question you also will see in Max chapter 4 of the Max 3. Okay, and then this one is very easy, it's very obvious, just like this question. The only thing is they just try to put 6 alpha minus 1 to confuse you. Okay, actually why? If you have a time, you go and try, then you will know that why the 6 alpha minus 1 exists here. Okay, now then over here we have a few of it, trigonometry. Okay, this is the one you learn in okay, the first one you learn, okay, although you look very similar, sine square, sine cube, sine 4. Okay, but you need to remember one thing. This one easily can change. Reason is you have a cos 2x equals to 1 minus 2 sine squared x. So this question is sine squared x equals to cos 2. Okay, this one, okay, it's become 1 minus cos 2x divided by 2. So this question is become integrating this one. Okay, then you already solve your problem. So this one actually is 1 over 2x plus cos 2x over 4 plus c. Okay, now but sine cube, okay, you already until this level. Okay, don't simply think of sine cube, then you give me sine power of 4. Okay, if you really put sine power of 4, if by chance I see you, I really will kill you. Okay, so please don't do so, because when integration is always not so simple like differentiation. Differentiation, if you want to differentiate sine cube x x is very simple. Just push the 3 in 3 sine squared. This is also squared. This is x